This was problem number 4 from assessment number 6. It says find the remaining 5 trigonometric functions of theta. Well, what are those functions? Well, they give us cotangent. So they know they're telling us that cotangent theta equals 5 over 12. We need to find sine theta. I'm going to write all these out. So the sine theta, we need to find cosine theta. We need to find tangent theta. We also need to find sine, we're going to call this cosecant, and secant theta. So we need to find all 5 of these. Now they give us cotangent, which is 5 over 12. They tell us a piece of information which says sine theta is greater than 0. What they're trying to tell us is, they're trying to tell us the quadrant that we are currently in. Well, if sine is greater than 0, let's go ahead and draw out our quadrants. So this is quadrant 1, this is 2, this is 3, and this is 4. Now, sine is greater than 0 in quadrant 1 and 2. Cotangent, where's that greater than 0? Remember, cotangent theta, if you look at your trig sheet, is cosine theta over sine theta. So where is cosine and sine, or basically the only time cotangent is positive was when cosine and sine are both positive, or when cosine and sine are both negative. Well, that means cotangent's only positive in quadrants 1 and quadrant 3. What do they share? Well, they're sharing quadrant 1 because we know sine is greater than 0 and cotangent's greater than 0, so we must be in quadrant 1. So as soon as I figure that out, what I want to do is I want to draw my triangle for quadrant 1. It's the most important thing you can do. And notice it's a right triangle. It's always a right triangle. Make sure you're drawing that like that. Now, cotangent is 5 over 12. Now, we can find tangent because we know that cotangent and tangent are reciprocals of each other. And if we look at our trig functions, we can see tangent is sine over cosine, cotangent is cosine over sine, so if we just flop this fraction, we know what tangent is. So 12 over 5 is tangent. That's easy. So then we can go and we can say if this is my theta here, I know tangent's opposite over adjacent. So I can say that this is 12 and this is 5. All right? Now once I find 5 and 12, I can find this side. And I can find that side using the Pythagorean theorem. So we can say that this, we'll call it x. So 5 squared plus 12 squared equals x squared. I know that's 25 and 144 equals x squared. So that's 169 equals x squared. And I take the square root of that. And I believe the square root of 169 is 13. I'll double check in the calculator. It is. So 13. Now that we know 13, we can find sine. Sine is the opposite over the hypotenuse. So that's 12 over 13. Cosine is the adjacent over the hypotenuse. So that's 5 over 13. I know from my reciprocal identities, cosecant is 1 over sine. So that's just the reciprocal. So cosecant's the reciprocal of sine, which is 13 over 12. And secant is the reciprocal of cosine, right? So that can be written as 13 over 5. And I have all of my solutions. So long story short, figure out what quadrant you're in, draw the triangle, use your piece of information that they give you to label sides, and find the third side, and then you can write all the trig ratios.